This is 5.3. We're going to start graphing trig functions, primarily sine and cosine. I've said it to you before, sine and cosine is the emphasis on figuring a lot of the other trig functions, so we're going to start with sine and cosine. So the sine and cosine functions repeat themselves every 2 pi. So think of the unit circle. So here we talked about the unit circle last chapter, and as we start moving around the circle, again, we're all the way around this 2 pi. And again, 2 pi is about like 6.28, blah, blah, blah. And so that's the distance. So as we go all the way around to 6.2, 6.3, 6.4, whatever. So as we start going around, we might go 1 radian, 2 radians, 3 radians, 4, 5, 6, all the way around to the unit circle. So as we start taking those, the amount of radians and start plotting those points, we can start seeing different functions, primarily the sine and cosine. Keep in mind also this is cosine and then sine. So at 0 radians, like I haven't moved yet, notice cosine is at 1 and sine is 0. So literally the sine function is at 0 radians, it's at 0. And at cosine at 0 radians, it's at 1. And we can literally go all the way around, but let's focus on the primary points, at pi over 2. And notice as I go pi over 2 radians, notice cosine is at 0. So at pi over 2, it's at 0. And at pi over 2, sine is at 1. Remember, cosine, sine. And then the same thing as I continue traveling around the unit circle, I have -1, 0. So at pi, this is pi. So at pi radians all the way around, the cosine is at -1, and sine is back at 0. And as I continue around the unit circle, notice here at 3 pi over 2, cosine is at 0, and sine is at -1. And then as I continue traveling around, the amount of radians, I get back to 2 pi, and then I'm back at 1 1 for cosine, and then back at 0 for sine. Now, once I plot these and connect these, you can see what this is going to look like. It's going to look like a wave, just up, down, up, down, up, down, and the same thing here. It's just it's a matter of noticing where they start at. All right, so that's the basic sine function and cosine function. Again, it's the way that you're doing. And by the way, it does keep going. Like if I could keep going around the circle 2 times, 3 times, 4 times. So this function continues on. It continues on. And the same thing if I wanted to go counterclockwise. So it would go this way. And the same thing with the cosine function. So this would keep going further and further and further. And then same thing, it keeps going this way and this way. It literally goes up, down like a roller coaster. Up, down, up, down, up, down for the rest of the time. Depending on how many times you want to go around the circle. So, and again, that's what I have here. So if you primarily just keep repeating yourself, you can see where it's at. Now let's just focus on one of those functions. Just to illustrate what I'm talking about. So we're going to focus on the sine function. Okay, so sine function. So the sine function, remember, starts at 0, and then it goes up to 1 at pi over 2, then it goes back to 0, then it goes to -1, then it goes back to 0. Now, what it's done so far is I've traveled 1 time around the unit circle. Okay, 1 time. And that's what it's going to look like. That right there from 0 to 2 pi is 1 period. So if you notice from here to here is 1 period. So I kind of skipped over it on purpose, this definition on the back, on the first page. So the period of both sine and cosine is 2 pi. So it literally repeats itself every 2 pi. And so a period is literally, 1 cycle all the way back around to get back to the beginning. So if I continued that cycle, you can see literally it just goes up to 1, back to 0, back here, back there, and it literally keeps going on, that same function. so notice from there to there, that would be 2 periods because I've completed 2 cycles. And I could do the exact same thing going this direction. Okay, so notice I have several periods graphed here, and obviously it keeps going on forever. So you can talk about the domain and the range of this as well. So the domain is all real numbers, and the range is literally from -1 to +1. Right, and that's just the sine function. And cosine, and as far as the domain and range, the sine and cosine are going to be the exact same thing. It's just a matter of where it starts at in the cycle. So, all right, so let's look at transformations now. So we've already talked about transformations with previous functions like log functions or quadratic functions or whatever it is. We've talked about transformations, exponential growth functions, ln. I mean, we've done several functions, but here let's talk about trig functions. Well, the number on the outside shifts it up. So here's a sine x. I'm going to stay with sine of x throughout this whole lesson, but you can do the same thing with cosine. So here's sine of x plus 2. Well, notice what it's doing. Instead of starting at 0, it raised everything up 2 spots. So it literally, instead of starting here, it literally went up 2 spots. And then it starts the cycle again. Okay, so it literally goes throughout the entire thing. So we've already done a lot of shifting problems, so I'm going to be kind of brief on these, but literally the number on the outside shifts it up and it still has the same function. So let's look at the negative on the outside. Well, the negative literally flips it over on the x-axis, so it's literally reflects it on the x-axis. So instead of going, it still starts at 0, but instead of going up to 1, it's going to go down to -1. It's kind of like going, the unit circle. Instead of going counterclockwise, we're actually doing negative. We're actually going clockwise. So here we have, because we're going in the opposite direction. So here we're going down and then back up, and then that's all the negative sign does. Now this 3 on the outside, we talked about this already. That normally what this does is it like stretches it or it compresses it, depending on what number that is. So this A on the outside is called the amplitude. All right, kind of like think of a radio wave. When you turn the volume up, the amplitude goes up on that. So the sound, it looks like a sound wave is just going higher and higher. Well, again, we're going to stay with the sine function again. And so the sine function, again, starts at 0 and normally goes up to 1. Like normally it would go right here. But the amplitude is being multiplied by 3, so it's going to go all the way up to 3. And then down to 3, and then back to 0. So it literally goes through the same sine function. Notice, by the way, I should have said this at the very beginning. The whole cycle is from 0 to 2 pi. And when you create these, your graph, just take 2 pi and then go to pi, half a pi, then half of that. And that's pi over 2. And then so notice you're counting by pi over 2. So 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. And so this is your typical cycle that the sine or cosine function would follow. All right, so here, what if I gave you this function right here? Well, notice the amplitude is 4. We've already talked about that. The amplitude is 4, so we're going to go all the way up to 4 on the graph and all the way down to 4, or -4. And notice the period. The period, remember, is how long it takes before it starts to repeat itself. Well, the period is, if you look at this number that's being multiplied by x, okay? If you multiply it by x. So, as a matter of fact, I probably should just write kx like this instead of both in parentheses. Because it's whatever's being multiplied by that. Okay, so the period is k times x. So remember, a period normally on the unit circle is 2 pi. So we're going to literally take 2 pi divided by k, whatever we're multiplying that by. And so that's, in this case, 2 pi divided by k would be 2 pi over 3. So it's going to repeat itself from 0 to 2 pi over 3. So notice I'm going to end the cycle or start a new one like right after 2 pi over 3. And then all I do is take half of that, and I have pi over 3, half of that, that's pi over 6. So I'm counting everything by pi over 6. So pi over 6, 1 pi, 1 6, 2 6, 3 6, 4 6. So think of it that way. It's like 1, 6, 2, 6, 3, 6, and then 4, 6. All right, so that's really what I'm doing. So again, this is important to find out because that's how often it repeats itself. And then let's look at one last problem, is shifting it to the left or to the right. So here, let's look at everything nice and slow. So if I gave you something like this, notice that's the amplitude. So it's going up to 3, going down to 3. Notice this number right here is 2. That's going to help us find the period. So we have the period, take 2 pi divided by k, and then that's going to be pi. So notice it's repeating itself every pi. Every pi, it's going to repeat, repeating itself. And then notice it's also shifting this over here. Remember, it's always, this looks like a negative. I mean, it is a negative, but so you're always going to be doing this to the opposite of what it says. You know, remember with parabolas, you know, if you had x minus 2 squared, you know, plus 7 or something like that. So this is shifting it 2 spaces to the right in this case. So here we're shifting it pi over 4 to the right. Okay, so all I'm doing, and again, don't draw an asymptote like sometimes we were drawing an asymptote on log functions or something. Like earlier, we had a log of you know, x plus 2 or something like that. We would move the asymptote 2 spaces over. So because log did have a vertical asymptote, here the sine function doesn't have the asymptote that we did in log functions. So, but we are shifting it pi over 4. So this is your starting spot right here. You know, right at pi over 4. So it's the same thing as starting like right here, but I shifted it pi over 4. And then it makes one complete cycle pi later. So again, it's not stopping at pi. From here to here is one period, which is a pi distance. Okay, so 1 pi plus pi over 4 is 5 pi over 4. So the graph would look like that. And again, I want to emphasize this again, it doesn't start and stop there. It literally keeps going on forever. Okay, if we could do one cycle, one period, then we know what the rest of the graph's going to be. It literally keeps going on forever, okay, in both directions. Okay, so just keep that in mind when you're graphing it. But typically we talk about one period of graphing sine functions or cosine functions. And then from there, we know what it looks like. And again, all the illustrations I did were based on the sine function that starts at 0, but you can do the exact same thing with the cosine function, which starts